Hey, I finally get to be recording this video. So this is a demo of what I have done so far. So what we have here is basically a web application that I made to control the cameras and more than anything to calibrate the rig. So what we have in this app is basically this UI that contains the calibration routine. We go through the calibration routine and then we are able to already take pictures that unwraps the cylinder core. So yeah, that's pretty much it. Right now, oh, also quick note. The UI that you see here, this is just a suggestive. I needed an UI to work on, so I made one, but this is all suggestive. We can always change anything if it doesn't, you don't like it. Also, the program is a bit clunky still. This is just a prototype that I finally got running. So yeah, I apologize in advance for any inconsistency or yeah. So what we see here right now is the cameras. The cameras are connected to the Pi, and the Pi is streaming the images to this app. The app is running on my desktop, but it's the Pi that yeah, that's basically running the cameras. I have the rig right behind me. I'll send you a picture of the rig after this, so you can see how it looks. But yeah, without further ado, let's move on to the calibration routine. Again, this was the first stage of the plan that I showed you, which is basically this, the code base and the calibration routine, which is everything that is working right now. So yeah, now we can move on to the calibration routine. So, no calibration available, let's run calibration. So this first stage, we are just telling the program what's the order of the cameras in the array. In this case, you can see it, but I already know this is the first one and this is the second one. I'm counting cameras from left to right. So this one is actually the one that is on the left and this one is on the one on the right. So that's what we are telling the program. So you can also see already, obviously, I have this board. This is a calibration board that I made to calibrate the cameras and the rig. So right now what the program does on this second stage, it detects the pattern and it's gonna undistort the images, calculate intrinsics, and yeah, that's pretty much it for this second stage. So I'm gonna do calibrate. And what we will see here is that it will undistort the image, okay? It's undistorted. So now, next camera, now I have to go there to move this. Okay, it's here, so I'm gonna do calibrate. And it will undistort the image, and internally it will also calculate the intrinsics of the camera. So next step, this is the third stage, and the goal of this stage is to calculate the extrinsics of the rig. So basically it will calculate the relative position between the two cameras, so we can align the images. So I am gonna move this a little bit towards the center so both cameras see it, okay? And I'm gonna run calibrate, and what we'll see is that this will align these two images. We wait a bit. And I also apologize for background noise. Data. Okay. It's taking some time to process, but it's normal. Okay. So as you can see, yeah, I'm happy with this. It worked quite well. So you can see that the images are very well aligned. So we could call this like a pre-stitching phase, because we are just basically overlaying the images on top of each other and calculating the average on the overlapping region. And we can see that it almost looks like it's just one image, which is the goal. So now Next step, this is the fourth stage of calibration. And the goal of this calibration stage is to tell the program in each camera where the cylinder core will appear. So I'm gonna go there and I am gonna switch this to a cylinder I have here. I made with some patterns so we can see it, how it works. It's a colorful pattern. And here we can select the type of the core we have. Here at Tomac, the most similar or the closest thing I could get is this cylinder to which I wrapped around this paper, and it's 58 millimeters diameter. So I'm gonna set this here, and what I'm gonna do now is I'm gonna draw a bounding box where the cylinder appears. Okay. Okay, it's good like this. So now we click unwrap. This is also gonna take a few seconds to do the unwrapping, and then we'll see how the unwrap looks. Yeah, it looks quite good. I mean, it's not perfect. We still see some curved lines here and here, but for the demonstration purposes, this is good enough. So I'm gonna move on to the next camera, and I'm gonna do the same thing. And looking good. So unwrap. Okay, good enough. So now at this point we can finish. And when we finish, now we go to preview and we'll see the pre-stitch. This doesn't look perfect though, because also this is being recalculated from the other alignment, but this is fine because this is just a preview. And what matters is what happens when we do render. The render is gonna do another alignment, automatic alignment. Basically, it's gonna stitch the images and generate the full resolution ortho strip, or basically the undeveloped surface of the cylinder core. So let's see how it looks, and it looks pretty good. Yeah, this is pretty much it. The image was saved here on my machine, so I can open it so we can take a look at it in more detail. Let me just find it. And it's this one. Okay, so this is what we created. Obviously, this is still not perfect. It's obviously there's room for improvement, and obviously the calibration routine itself can maybe be improved, so maybe it's more intuitive and stuff like that. But the goal with this demonstration, or with what I've done so far, was to basically have the basis for what we can use and work on. So the goal was code base, calibration routine, and we have our scans. And yeah, this is pretty much it. This is what I wanted to show you. I'm actually quite happy with this. Maybe it could be that this is not what you were expecting. I hope it was what you were expecting. So yeah, please let me know what you think. And again, this is just a prototype. This is nothing final. It's not a final product whatsoever. It's just the progress I had so far. So yeah, I hope you like it.